Okay, this is a short introduction to a Python graphics library I made called Pixpy. I realized that I've been playing around with it for a while and it's actually pretty usable and fun. So it's on Pixpy, so you can just download it. And I'm on Windows now. This works for Mac, Windows and Linux. Windows is my least favorite operating system, so I thought I'd try it here just to make sure that it works for everybody. So, well, you need Python installed. I'm assuming that you have. So let's check. Yes, Python 3.12. So, pip install Pixpy. So, I already have it, of course. We can... So what do you say? I don't know. See how long it takes to install. It's just... There we go. So if you do this on OS X currently, it will not work because Python 3.12 requires a virtual environment, or that you specify a certain flag to override it doesn't allow global packages by default, but you can override it if you want to, or just create a virtual environment. Okay, so let's try this. We have Visual Studio Code, so let's go to here. So the packet is called Pixpy, so we need to import it. I usually alias it to Pix because it's two characters fewer to type. So let's open the display. So you can see here we have two overloads. I usually like to use the int2 and the float2 are two types that are part of Pix that are used for coordinates and sizes. Which makes things nicer. So let's say size. Okay, so that's the screen. And what can we do with the screen? We can draw a circle or a filled circle. And what we can do here is we can say this is the benefit of using proper types for coordinates and sizes. I can say I can take the screen size divided by 2, which should place us in the center of the screen. And let's just do a radius of 3, and let's run this. See what happens. Yes, as expected. So this is more or less the simplest program you can write. Normally you will want to have a render loop. And it looks like this. Run loop. So run loop calls the render loop and returns false when the application wants to quit. While run loop. So now we do this. We clear the screen, we draw the circle, and we swap the screen buffers. So at this point this should look exactly the same as before, which is a bit boring. So let's make this move. So we will say start at 300 and screen size. So center on the y-axis, but outside the screen on the x-axis, and something like that. Then we get the scrolling. So this is a basic program. So to show off some more stuff, I am going to clone my, yeah, let's do this. Here, clone repository. Clone from GitHub, and this is my examples repository. Let's delete the old one and open. Okay, so here we have a bunch of examples. We can see like example 1 here is more or less what I just shown you. These are very small. This one shows image loading, but still does similar things. So the basic things you can do with Pixpy is like you saw, just drawing stuff on the screen, but you can also use something called a console, which is for drawing text and reading text input, but also for making games based on tiles. And you can also draw polygons and points, and of course you can read the so let's start with the console. We have some simple, but just here. Okay, so this opens the display like before, and this creates a console, which is a so it should be this many columns, this many rows, and then we just say write text and read line, and this does what you would expect. And this is a proper, you can edit text and delete and such, and this will scroll. But the console is not only for text, this is also for tiles, as I mentioned. So it starts out by default with a backing font, so you get access to all the characters you can do right like this, but you can easily change the tiles in the console. So what we can do, for instance, we can load an image. I have an ugly ball image, I think, called ball, and now that we have that image, we can do this. We will say things on the get image 4. So we want to get the image for the O character, so we ask the console which can we get a reference to the image for the O character, and then we can say copy from image. So what this does, it will take the image and render it on top of the image represented by the O. So if we run this again, yes, and this is the O character now. So if we want to look at something a bit more advanced, we have, for instance, this Sokoban game here. Let's find the init here. Yes, we init as usual. Open display. Here's the console, and this is how you normally define tiles. We have this tile sheet. We can look at it here. It should be in the data folder. Sokoban tile sheet. Yeah. So these are the PNG of all the tiles, and so what we do is we load this PNG, which gives us a large image, and then we call the split method, which will produce a list of images by just splitting the image into 64 by 64 tiles, or tiles that have this size. And this is also cheap. This does not actually create new images. It just these are just sort of views into the old image. And then we iterate over the tiles and do like before. We get the image for a certain tile and copy the tile into it. So this means that now tiles with number 2, 5, 6 and above will reference these tiles in the tile set, and that makes it easy to use these tiles in the game. So if we run this thing, it's a cute little Sokoban game. And it seems to work. Do we have something else that is fun to show? This is a very simple example showing how you can do sprites and animations. We have this directory data night. Let's see what that contains. It contains a lot of PNGs, and each PNG is an animation of this character. So what we do is we iterate over all the files, over all the PNG files in this directory, and we load that each image, and we split it into the two frames, similar to what we did with the tiles, except in this case we actually store it in a dictionary, where each entry in the dictionary is the name of this animation. So we have walk and run, etc. So now when you say this here, sprites run, this will get a sheet, which is a list of images for that animation. And we draw, we calculate the frame, get that particular image and draw it. And we also read the keys here, which means this is a very simple example of a character that can run from left to right and animate. Take a look at some. We have this actually uses NumPy, which does some math. It's not too long, but this actually has the vertices, normals and chords for a cube, and has a star field as well, which is created by taking 3 images and drawing dots on top of the images to get 3 fields of stars. And then the cube is drawn as a set of polygons, and it looks like this. Okay, I am going to stop for now, and hopefully I'll be back with something more later.